The dais, all the guests who are here, both from Defense Forces and from DRDO labs and industry, and ladies and gentlemen. At the outset, I would like to thank and express my gratitude to Sanjos for inviting me for this talk today. And also, I would like to compliment Sanjos and the Indian Military Review for choosing this very relevant topic, that is military power systems, for the seminar today. This topic is not as glamorous as AI and big data analysis or quantum, but I think it is very, very relevant, if not more than them. As most of you are now aware, I am an elected officer in the Navy. I have served, now I'll be completing 39 years of service this December. And I've also commanded our electrical training establishment. This is in Jamnagar, INS Valsura. So I've been dealing with electrical power systems for the last 4 decades. I was also the manager electrical power systems. This is MEPS, is a naval dockyard Mumbai. And this repairs, rewinds, installs alternators, motors, all converters, transformers. So the whole gamut of equipment. So anyone is interested in seeing how actually motors are rewound or transformers are rewound, refurbished, baked in oven, you can go to Bombay, and we have a similar thing in Vizag too. Also, I have served on the aircraft carrier Virat for 3 tenures, and Virat, the erstwhile Virat, had 9 megawatts of electrical power. We had 9 generators, each of 1 megawatt. They say that carrier runs on power, is electrical power, but in the end, in the last few years of Virat, it was not only electric power, it was also willpower of the people which took Virat forward, and we sailed it for many, many years after it was decommissioned from UK. The Navy uses all types of power generation equipment like diesels, gas turbines, also nuclear. We also have a ship which is inducted recently, which runs on electric power. Our submarines run on batteries, as you are all aware, and now we are planning to induct lithium-ion batteries for our submarines. As Dr. Roy Chaudhary, who is sitting here, will inform you later today, we are also developing the air-independent propulsion, the AIP, for our submarines, which are based on fuel cells developed by Admiral, actually developed by him personally. So we have a luminary amongst us. You should be hearing him later. In the next 7 or 8 minutes of my talk, I'll be highlighting some of the progress that the Indian Navy has made in the various subdomains of military power. That will also give our industry representatives present here a broad idea of the collaborations we can enter into later. So our military power systems today are not only technologically advanced, but also serve as the backbone of all major systems on board, like weapons, sensors, communications, machinery controls, etc. So from the forward operating bases to naval vessels, the efficiency and effectiveness of our military operations hinge upon the strength and adaptability of the state-of-the-art power generators and the associated systems. So my talk today will be classified into 3 subgroups. One, I will cover the power generators and associated systems that are employed on our platforms. Then I will also bring out the ongoing efforts which we have in certain specific power systems. And finally, the opportunities that are available to our industry partners for providing solutions to our requirements and the government policies towards that. Before delving into the specifics of power systems, I would like to provide an overview of the various types and the quantum of power that the Indian Navy generates on board our ships. This will offer a comprehensive understanding of the challenges and opportunities in the military power systems of the Indian Navy. The Indian Navy has seen an unparalleled growth in power generation capabilities, wherein the capacities on board naval platforms, the ships, have varied from a few 100 kilowatts to now many megawatts. As I mentioned earlier, Virat had 9 megawatts of electric power. To put things in perspective, INS Vikrant, the indigenous aircraft carrier, generates 24 megawatts of electric power. And to draw a comparison, This is sufficient to fulfill the energy needs of the street lighting of Chennai. It is about 19 to 20 megawatts, the requirements of street lighting of Chennai. So along with other associated systems, we have a highly trained team of personnel who operate and maintain these systems and have been doing so for decades on board our warships. And also we have many civilians who are trained in electrical power systems who are working in our naval repair yards. An interesting fact about the power generation in the Indian Navy, as I alluded to earlier, are its various types of power generation methods which are on board our ships. The Navy has been operating varied power plant technologies comprising steam engines. Then we have diesel engines, we have gas turbines, batteries, and also nuclear technology. While the management of power being generated on board, our ships have transited from the manual system to the now fully automated systems. We have, however, not been able to fully achieve the goal of a completely unmanned switchboard, which exists in merchant ships. And this is due to various reasons, especially pertaining to reliability of the automated systems. This is where we would like our industry partners to augment our efforts towards developing an intelligent power management system, which should be fully automated in the true sense, and this will enable us to completely do away with manning such switchboards. My next part of the talk will deal with the advancements that we have made in certain specific power systems. In our quest for keeping pace with contemporary technologies, intelligent power switching devices, that is automatic transfer switches, have been inducted in the Navy, and this is done for mission critical equipment where the dwell time is lower than that catered for the conventional UPS. The power switching times that have been achieved are in the order of a few milliseconds. We are also aware that reliable backup supplies are critical for war-going platforms in the pursuit of having a resilient power supply system with adequate backup for critical equipment. There is a tendency to install COTS, uninterrupted power supply, or UPS. But our word of caution here, we have had some safety issues, some fires on all these COTS UPS. So now we have, because of the environment conditions which we have on board. So what we have done is that we have migrated to ruggedized marine UPS. We have standardized these to about 12 types based on the capacity. They are in the process of being sourced and inducted on board. Another key technology being pursued by the Navy in the domain of military power systems is the inertial energy storage system, or IESS. I don't know whether you've heard of this. This, in the event of a interruption in the main supply, the kinetic energy of a flywheel is converted into electrical energy and fed back to the consumer. A practical use for this technology would be the availability of backup for critical mission systems like the steering gear on board ships. This is a technology that we have very recently ventured into and is still in a nascent stage in the country. Again, we would welcome our industry partners to explore possible solutions in this domain. Availability of space is of great concern on board our ships and submarines, and there is a continued endeavor to have items which are smaller, equipment which are smaller, and having equivalent or better functionalities. For example, a destroyer on board has 450 motors on an average and of varied power ratings. And if you extrapolate to all classes of ships in the Navy, so we have 20,000 motors in the Indian Navy. Therefore, the Navy has engaged with technology startups, and we are working on in the field of rotating machinery and development of an axial flux motor, and this is being pursued. So again, in the industry, if you are working in this field, because what we understand is we will have a size and weight reduction of about 50% compared to the conventional motors for any power rating. Batteries are another important part of the Indian naval inventory. These are especially critical when it comes to submarines, and they form the backbone of all power supplies on board. I don't know whether you have seen a submarine battery. It is about 6 feet in height. It is quite huge, and we have the charging is done in a charging facility. It's called a BCF, battery charging facility. We have one in Bombay, one in Vizag. Again, a very interesting place to see. If you have a chance and you want to see it, it's in Vadala in Bombay. It's in Vizag in the naval area. Go and have a look. It is interesting when you see those huge batteries. We are also planning to get into lithium-ion batteries, which are supposed to be smaller in size, more energy efficient, and this we are working out with the industry and the DRDO. The Government of India's flagship National Electric Mobility Mission plan, which of 2020, which has provided a vision for and roadmap for faster adoption of electric vehicles, gets into this aspect of developing the domestic R&D ecosystem for lithium-ion technology. So Indian Navy, in consultation with NSTL, which is in Vizag, and some industry, HBL is there. Then we have Bell. They are tying up with Toshiba. So with all these partnerships, we are planning to develop lithium-ion batteries for our submarines. With the known pros and cons of various chemistries, there are various chemistries for these lithium-ion batteries. We are looking again for participation with of the industry, if you can help us out to in this niche technology. Moving on to electric propulsion, which was alluded to by the General Srivastav. We have seen in the foreign countries, we have an aircraft carrier which has electric propulsion. We have Zumwalt destroyer which is electric propulsion. And there are pros and cons of going into electric propulsion because it will be a new technology and we have to work, we have to train our people. Right now, India is not, the Indian industry is not geared up to or mature enough to give us all the aspects of electric propulsion. Here the voltages will go up to 6.6 kV and 11 kV on board. Right now we are used to only 440 volts. So the production, what is to be done, we also have a MV lab of this high technology in Valsura. So anyone wants to see how electric propulsion will look in a ship, you can go to Jamnagar, Valsura. A whole lab is set up for last 3 years. We are training our people because at some time we will get into electric propulsion. Also we have, as I mentioned, one ship is there in Kochi which has electric propulsion, is a new one. And the issue why we have not inducted yet is because we will have to import the technology here. When you import, there are a lot of issues because we are concentrating on internationalization and Atmanirbharta. So how will we get the spares later on? How will we manage the life cycle? Is not very clear. We have also have a Make One project as far as electric propulsion is concerned. We have the industry coming into this. There's one Medha company in, I think, Secunderabad, which makes electric motors, huge motors. We have BHEL. So all are collaborating. So maybe it'll take some time when we have an indigenous electrical propulsion aggregate, and then we will dabble into this technology on our warships. While till now I've been dwelling on warships, the problem of finding satisfactory forms of propulsion underwater still persists as far as submarines are concerned. We have gained a lot of expertise in using diesel engines for our propulsion. So diesel engines actually, as you are aware, submarine runs on batteries. It's electric power, but the charging of the batteries is done by diesels. So now we are getting into this air independent propulsion. This will actually augment the power on board and will enable the submarine to stay underwater for a longer period. And that is again, you can ask all the questions to Dr. Roy Chaudhary when he delivers his talk. And I would like the industries to help him to make a product which is the best AIP system for our Navy. Another issue which is important is the timely testing, tuning and repair through a robust and effective maintenance infrastructure. And this is very important for us because we have so many electrical equipment on board. And to this effect, the military power systems are actually no different, and therefore they require focused attention. For this, the Navy has set up a unit which is called Electrical Trials and Maintenance Authority, or ETMA. This is based in Mumbai. We have satellite units in Vizag, Kochi and Calcutta, and they are the ones who set up standards for what should be the specifications for our equipment, electrical equipment. They do all the trials, they do the induction trials also. We have the load trials of all our generators, and they have sophisticated equipment. I don't know whether you heard of storage oscilloscopes. A lot of things are being done by them, and so again, the industry, if you want to see how trials are done, what are the specifications we have, you can tie up with ETMA. Other services also, you want to see major electrical power systems, how are they, how do they run, what are the issues, you can have a look at ETMA Mumbai. We are also changing the load banks, though it is a different topic. Earlier we used to have those water tanks with salt water, and that was the load. Now we have inductive load, complex load, which is easier to move and use when we are doing the load trials. And coming to the last part of my talk, which is opportunities for our industry partners. In this, as I mentioned earlier, automatic power management systems is a weak area for us. This energy storage systems, which I had mentioned earlier, IESS, etc., where we need your help. And lastly, electric propulsion. All these are at a nascent stage, so the industry can help us in this, put more R&D efforts, and then come out with a solution. Also, what has happened is we have had many seminars. I don't know whether you have attended the Swavlamban 2.0. Earlier I had 1.0. This was done in Bharat Mandapam, where we have brought out whatever the Navy requires in all domains. Electrical power is only one part of it. We have a document called Swavlamban 2.0, and this was released by the Honorable Raksha Mantri in October this year. So it is available on the internet. You can just see it and at least come to know what our requirements are there. So while I've tried to give you a broad perspective of the ongoing efforts of the Indian Navy in the domain, the road ahead is full of opportunities for our R&D establishments and the industry, as there's tremendous scope for indigenous replacement of foreign origin systems. There's one thing which I'll just speak as an aside. Outside in the civil world, things are galloping at a very, very fast rate. We are not keeping keeping a pace with them. For example, in Kochi, they have these water metro. You heard of those boats? There are boats which are connecting all those backwaters which are there, and they are all electric boats. This is made by Cochin Shipyard, but again, the issue is that the technology is from abroad. So they go, they charge, again they start moving, and this is being used abroad everywhere. Also, we have heard of wireless charging. All of us have watches. So how do we take it forward for our defense, for military power systems? Can we do wireless charging and bigger things? So there's so much we can discuss on new technologies, but that was not my topic of the talk today. But anyone has any interesting ideas, let us know, because what we have said in the Navy is that other than electric propulsion systems, whatever we see in the Mission Impossible movies, Tom Cruise movies, we want it in our defense. That's what I tell the industry. जो भी नया कुछ देखते हो, we want it, and we'll be there to support you and see that we take it forward. Thank you so much for all your attention, and I wish the seminar very healthy deliberations. Thank you. Jai Hind, Shano Varuna.